And we've got an example of that down here. I'm just going to do the first one of these and then see what happens when we change the time. So we've got a driver of a car that doesn't have an airbag, and he's travelling at a speed of 20 meters per second when the car hits a wall. And we're looking at the driver's head, which, and this is a fairly gruesome example, hits the steering wheel and stops in a time of 1/100th of a second. So we want to calculate the force that impact generates on the driver's head. So we want to calculate the change in momentum, and then we want to find the force that generates. So the change in momentum is going to be mv minus mu, and for that we're going to have a mass of 5 kilograms. Now the final speed is 0, so we want minus 5 times 20. So that's going to give us a change of momentum of effectively minus 5 times 20, which is minus 100 kilograms meters per second. The force that generates is going to be equal to that change in momentum divided by the time taken for that change. So we've got minus 100 divided by that time, which is 0.01 seconds, which is effectively the same as multiplying by 100. So we've got 100 times 100, which is minus 100, and the next two noughts, minus 10,000 newtons. That's quite a large force, and it's because the time taken to stop is so short. It's only 1/100th of a second as the driver's head hits that steering wheel. So let's have a look at what happens with an airbag, for example, and let's actually move this this equation here. Let's move it down here, because what the next question is saying is, rather than stopping in a time of 1/100th of a second, we're now stopping in a time of 1/10th of a second, 0.1 seconds. So if we change this value down here, rather than it being 1/100th of a second, if we change it to 0.1 second, we're dividing it by a number which is 10 times as big, which means the answer is going to be 10 times as small. So multiplying this by 10 has the effect of dividing the impact force by 10 as well. So you should be able to see that increasing the time tenfold reduces the impact force by that same factor, by a factor of 10. And therefore, the force is much less because the time taken for that change in momentum is much more.